Hey everyone, it's Mr. Edwards. I'm back. Today we're going to be talking about inverse trigonometry. So we're going to be still using sine, cosine, tangent, and all those, but now we're going to talk about what that means when you take the inverse. My goal is for you to be able to determine an angle if you're given a trig ratio, and also just to be able to solve problems in general using trig functions. So to start off with, before we actually define the trig functions, I want to give you a quick example to show you that a lot of this you can do without even using inverse trig. So for example, let's just say I gave you a problem that said solve for theta. So in this case, we're solving for the angle. And we'll do two different problems. The first one is cosine of theta equals, let's do the square root of 3 over 2. So cosine of theta equals the square root of 3 over 2. Now, at first glance, this doesn't really seem super easy, but hopefully you're getting pretty familiar with the unit circle. So if you go over here, I did a Google image search for unit circle. If we just click on one of these, notice that cosine gives me the x value. And so if you look where the 30-degree mark is on that unit circle, or the pi over 6, you'll see that x is square root of 3 over 2. So if I were to just draw a rough sketch of that, maybe off to the side, we're looking for when x is the square root of 3 over 2, which happens at 30 degrees or pi over 6. So in this case, we could say, well, the answer is just pi over 6. Now, if we were to look back at the unit circle, we would also notice that if I come around to the other side of the x-axis, so if I go this way, I'm also going to have the square root of 3 over 2, but it'll be negative 1/2. However, notice that the x value is the same for each of these angles, so we could also say that theta equals negative pi over 6. There's also other options which we'll come back to, so there's many other choices, but for now I'm not really interested in those. I just want to show you that you could actually come up with a solution just using what you know about unit circles. Okay, let's try another one. So if I said tangent of theta equaled negative 1, tangent's always a little bit trickier because you have to do an extra step, but keep in mind on a unit circle at 45 degrees, x and y equal each other, and tangent is the x and the y divided by each other. So if you took root 2 over 2 divided by root 2 over 2, it really doesn't matter that we have all these square roots and things. They're the exact same number, so they would just equal 1. Over on this side, however, it's going to be negative root 2 over 2. Feel free to double check your unit circle on this as well. And so in this one, we would end up with negative 1 for tangent if we divide those. So you might say, well, I know that tangent equals whatever that angle is, which comes out to 135 degrees. Or over here, we're also going to get negative 1. So if you look on your unit circle for that one, you should end up with 315 degrees for that. And again, there's many other choices as well. We really just care about one of them, so I would just expect, oh, there's the answer. Okay. So up till now, we haven't actually done any inverse trig. I've just given you some problems, and you were able to use the unit circle to actually find the solution. Let's switch it up now, and let's say I wanted you to solve for theta, and I gave you something like sine of theta equals 4 over 5. Now, this one's a bit trickier because it's not on a unit circle. You could probably estimate, so you could actually sketch a rough graph of a unit circle, and you might say, well, 4, 5 is here, And so you could say, oh, I think I know what that angle is, but you wouldn't know for sure. So here's what we're actually going to do. We're going to use inverse trigonometry. And for this problem specifically, we're going to use sine inverse, which is represented by sine with a -1 on it, or sometimes we use arcsine. I often use the -1 just because it's easier to write, but arcsine, you'll also see that a lot. And so all that happens is, if we're solving this, sine of theta equals 4/5, we sort of want to move, in a sense, we want to move the sine to the other side. But we can't just divide both sides by sine, so what we're going to do is rewrite this as theta equals the inverse function of sine, which just looks like that. Or you could write arcsine of 4/5. And this is not something I know off the top of my head because this isn't on a unit circle. So I would actually have to pull out the calculator. So let's go back to our calculator here, the Desmos Scientific Calculator. And I want to use sine inverse of 4/5. Whoops. Notice that there's a button here which I'm clicking. That changes your calculator from radians to degrees. Oftentimes when we're doing these problems and we don't have something in terms of pi, right? This radian, I have no clue what that is in terms of pi. So we usually use degrees, and I often round to just 1 decimal place. So we'd say that the answer would be 53.1 degrees. So theta is approximately 53.1 degrees, which kind of makes sense based on my picture up here. That looks like an angle that's larger than 45 degrees, but maybe not quite 60. So that kind of makes sense. About 53 degrees seems right. Let's see another example using, let's do tangent this time. So we'll do tangent of theta equals, let's just say -12/5. Okay, so once again, we're going to use inverse trig because this is not on the unit circle. And we'll say that theta has to equal tangent inverse of -12/5. And go to the calculator here, get rid of that sine. We have to go to the functions tab, click on tangent inverse, and then I'm going to do -12 divided by 5. Make sure I'm in degrees mode. -67.4 is my approximate solution. Okay. So in essence, this is really the main part of today's lesson, is really just you're given some sort of trig equation and you have to solve for the angle. So let me just write that as kind of a summary. We'll do some more stuff in the next videos, but really a big takeaway from today's lesson is just using inverse trig functions to find angles. In the next videos, we'll talk about some additional problems you might be able to do and some issues that come up, because there's always going to be issues that come up.